let's have a look at classes and what they are. So what do we have here? Well, looking at it, we've got a plan. It's a blueprint. It's an architectural drawing. There's lots of things that you can say about it, but it is the blueprint for a house. And this here is the house that was built from this set of plans. Okay, so we're quite familiar with this concept of having a blueprint and then we build from it. And we see it. This is the manifestation. This is the instance, and that's a great word for us to use. This is an instance of the plan. Okay, so it's an instance of that previous plan. Creating objects is going to be something done in a similar way. To create something, we require a plan. We require a blueprint, as we saw in the architectural diagram. In object-oriented programming, these blueprints are known as classes. Okay, so we define a class, and then from that class we create an instance, which will be an object. Okay, but before we create an object, we obviously need the class first. Kind of makes sense. And then, as I've said, we create an object from the class. Now, what a title, Nouns and Verbs. When it comes to this construction of classes, okay, there's a science to it and there's also an art form, and it's something we need to be aware of. Often there's the science and the art, and they work hand in hand, and we become good designers through practice. Now, one of the techniques we can go about using when it comes to creating classes is this one called the noun and the verb approach. Okay, and what we do is with the nouns, okay, get mapped to classes. All right, that's pretty straightforward. The class name, well, that describes the thing that it's going to be. So it might be a person class, or as we've seen, a car class, these kinds of things. So that class name describes the thing that we're talking about. We saw a pen, okay? Now, the verbs, the doing words we used to be taught in primary school. It's the doing words, okay? Now, these things, the verbs, these become the methods, which makes sense because the methods do things. They change things, they set things, they access things, they calculate things. Did you notice that? It's the action word. So the verbs map generally with our methods, okay? And our method names, they describe the action, all right? So it might be get name, access name, things like that. Now, when it comes to defining a class, what we're looking at is we have the name of the class. That makes sense. We have the attributes, all right, the attributes of the class, and then we have the methods. So that could be also data, and this could be behavior. And I don't know if I've spelt that correctly, but who cares? So continuing with this defining of classes, okay, as I've said, there's those three parts to it: the name, the data, and the methods. All right. So the class definition, this is really an interesting one. A set of program statements listing each object's characteristics and the methods it can use. Characteristics, we've sort of said attributes in that sense, and the methods it can use. So that's defining classes. Now, a class, what is it? Well, specifies the state and behavior that an object... What? Okay, it defines the state and the behavior. And if you think back to that house plan, all right, the house plan does that. It defines everything about what the house is going to look like and what you can do in there, in that sense, okay? And when you say it doesn't define what you can do in there, you generally don't have a bath in the bedroom. You have a bath in the bathroom, okay? It does define it. Now, the state, that's the values of the object's attributes. Values of the objects, and that should have an apostrophe there. Objects' attributes. okay? Not there. Should have it there, shouldn't it? David will get his English correct. Now, what does this mean? Well, the value of the object's attributes. The objects are called the objects. The attributes are the class fields or instance variables, and I will use those two interchangeably throughout the semester. Okay, we've got the behavior, what the object can actually do, and this is the methods or functions. Okay, so methods and functions can be used interchangeably. Generally, when it comes to OO, methods is the word that is used, and Java always calls them methods. So what is an actual object, I hear you asking? Well, I didn't really hear you asking it, but what's an object? Well, it's a collection of related information, of data. Data inside an object. Okay, so when it's inside the object, it's what we said, the class fields or the instance variables. And you're saying, David, you've said this already. I know, and I'm saying it from a slightly different angle because it's crucial you get an understanding of this. Okay, and our operations are the methods. So classes, objects. Hopefully by now they are making sense and you understand the difference. Okay, but the class is describing, the object. Okay, so an object is created from the class specification. Remember the house plan and the house. Okay, yep, the house analogy. The construction plans, they're the equivalent of the house, and the house itself is constructed from the plan. That's like the object. Okay, now each house conforms to the plan, okay, in the same way. Okay, but each house is built in a different location. Kind of makes sense. Each house has the same structure, but it has different things inside of it. Okay, different values of its attributes. Okay, the house plan is the class, the house is the object. Let's have a look perhaps here at this car class. Okay, so we've got a car. Now we've got the attributes of our car, and I've said there's a make, there's a model, there's a year, a color, a fuel level, and a speed. Excuse me. Then we have methods, and we have a lot more methods than what I've listed here, but we've got a method that allows us to change speed, okay? And we have a method that allows us to change the fuel level, okay? Because the fuel level changes, and we need to be able to track that. Now I'm going to take it from the car to a Formula One car, okay, with its attributes and its methods. So you notice our methods and our attributes are the same, but now we start out here with our values. So the make is, we've said Ferrari, the model, the SF21. The year, we've called it the 2021, should be really 2022 because it's a much faster car. It's red because it's a Ferrari, okay? Speed, 330 kilometers an hour, okay? And we have a fuel level. And see, this is where the art and the science cross, because I'm now going speed, 330. That's what we're really saying. That's the speed it's traveling now. Maybe we should have one that, what's its maximum speed? Anyway, we change speed when we accelerate. So that's when we would use that method. And our change fuel level, well, that's the method that's being used to tell us how much fuel is in the car. Inheritance, really big one, okay? Now, inheritance gives us the opportunity and the ability to create a hierarchy of classes, okay? And this becomes really important as we start to develop systems, because we realize there's things within a system, okay, that we start with a generic thing and then it becomes more and more specific, okay? So when we create a new class through inheritance, it's built on an existing class, okay? And when it's built on an existing class, it's called a child class. And this child class inherits everything from the parent. All of its attributes, that means all of its class fields or instance variables, and all of its methods. They are all inherited into our new class, and then we can add more things in our new class. Okay, so say a class inherited from is a parent class. So the Superclass, the parent class. Okay, just like you have inherited traits from your mum and your dad. And our class that inherits, all right, that one is called a child class or a subclass. Let's have a look at an example. We've got a person. Now, we have a generic person, we have an employee, and an employee is actually a person. We have a manager. Now, a manager is also an employee and a person. Starting to make sense? So a person, an employee, and a manager, if we start to think about it, all have the trait, all have the attribute of a name. Now, a person, for instance, doesn't have a staff ID, okay? An employee and a manager both have staff IDs, okay? And an employee doesn't have a list or a number of subordinates that report to him or her, but a manager does. So you can see that hierarchy. We start with a person, and then we can go down further to an employee, and then to a manager. And the employee has everything that a person has, and a manager has everything an employee has, keeping in mind that the employee also has everything a person has.